this, and so it probably said something, ew, now recording. So I did record this mornings as well locally to my computer. I got it uploaded to my personal YouTube. I don't know what they were planning on doing with these recordings, but I will send it on to the right person at the right place whenever I'm told, if I am told. So let's go ahead and I don't see Lynn here yet, but we can go ahead and she can dive in when she gets here and join us. I'm going to share my screen over here. And so I was saying earlier that the special session organizers, because they didn't know they had this extra session until very late in the game when I volunteered, and they gratefully accepted a late submission to do this workshop for y'all. So we're self-moderating, but that's okay. We're just going to have some fun taking a look at the Pi base. What the heck is it? What does it do? Why should we care? And what do we think the future of it is? So my plan is basically to give you a tour of and I'm going to go ahead and repeat myself a little bit because I did spend 5 minutes showing this off this morning, but just in case somebody was not there, let me just give everyone a crash course in what it does. And so it's, at its basics, there's not a whole lot going on, but it does what it needs to do. The Pi base is a database, and it stores three things: topological spaces, their properties, and the theorems that connect those properties. And I should clarify that this is a ZFC database. Hang on, let me get my headphone plugged in. It's beeping at me. This is a ZFC database currently. So I'm going to probably mention here and there, oh, it'd be nice if we did this. It'd be nice if we stored axioms, and then we could like tag, theorems and the existence of spaces based on what axioms you're assuming. We don't do that yet. We're not there. Something I've thought about, but not I've cracked, or we've cracked, I should say. Speaking of which, when I say we, who am I talking about? So the Pi base was not my project. It was not my original project. I was doing another software-ish project with James at the time, but this was his baby. James Dabbs is another student of Gary Grunhag, got his master's degree around 2014, 2015. And then he's a professional software engineer at Procore, I think is the name of his current company that he works for. Anyway, making the big bucks, works on this as a hobby still. Very grateful for his expertise and mentorship on this and various other cyber infrastructure products I've been working on. I guess I'm the next in command. I joined the project in 2017. I've been the lead mathematical editor, the self-appoint pat on the back, like, okay, I'm going to be responsible for making sure these things get reviewed. I'll show you what that looks like in a second. And trying to really just being the cheerleader and trying to get a few more folks involved. Speaking of which, we really have three main contributors to the Pi base currently, one of whom is Chris Caravana right here. And one of whom, of course, is Lynn Younglap, who most of you know and spoke with me in this morning's session. And then the third contributor is actually a hobbyist topologist. I'm pretty confident. He's a retired software engineer who had a degree in mathematics and came across the Pi base. Patrick Rabel, I don't know how to say his last name. Patrick has been a very frequent he's been a champion in terms of making a lot of the contributions to the Pi base in the last couple of years, especially when I was distracted trying to get tenure and other things, and now I have more time to work on this now that I'm tenured. So I wanted to thank all those folks. Various other folks are also thanked in the footer of this page as well. But as I said, we have spaces, and so you can search for these spaces by, word. So here's all of the spaces whose name or their description involves the word Cantor. Or you could search by property. Here's the non-metrizable continua. Here's first countable, separable, but turns out they're not all second countable. And you could, of course, type these out for yourself. So compact plus anti-compact. because yes, there are plenty of spaces, they're all finite, but there they are, that are both compact and anti-compact. There you go. So of course we store all those spaces. We have to store the properties. Every one of these things gets a little tag. If you're familiar with the OEIS, the Open Encyclopedia, I'll pull that up. That's probably the biggest math database that's out there that I'm aware of in terms of ubiquitousness and usefulness across mathematics. So here's my favorite is 1, 1, 2, 3, 5. I just found this neat pattern. No one's ever come up with this before. Oh crap, they have. It's called the Fibonacci numbers. So there's a lot of inspiration here from this idea that I want to describe something vaguely, but semantically for us. I'll show you that in a bit. And so this is what we've got. So we don't have a bunch of sequences. We have spaces. We have to store their properties. Everything gets its own little ID. So just like the OEIS has like A 1, 2, 3, 4, 5, 6 is the canonical ID for a particular sequence, and that kind of gathers the community around a name and a source for that type of sequence. We have IDs for our spaces, properties, and theorems. This is very helpful when you have concepts such as K omega, which have 3 different reasonable interpretations if you're not assuming Hausdorff, which we do not. We do not assume any separation axioms by default. In fact, our very first properties are the separation axioms, the T1 separation axioms, I should say. So we're trying to do our best to be pretty abstract, model stuff in ZFC, and not conflate things. Although I have some thoughts on the times when you really want to. We often love to assume everything's T2, and then how does that collapse down? Well, for me, if you just want everything to be T2, you can just search for T2 and just have that as part of your. But having this as like a global setting for the pi base. I want to use the pi base, and whenever I use the pi base, everything's T2. Certainly technically possible, not implemented yet. Finally, the coolest thing, of course, the thing that really makes this awesome is the theorems and the automated deduction stuff. For example, I showed this earlier. If I try to search for compact plus Hausdorff plus non-normal, we're going to be told that's dumb. You can't do it, because even though we don't have a theorem that says all compact Hausdorff spaces are normal, we do have theorems that say a compact space is exhaustible by compacts, a Hausdorff exhaustible by compact space, sigma locally compact, I believe that's another common phrase for that. Yep. And then finally, that's T4, and of course T4 spaces are normal. So it can do that. It can make those little leaps for you and make that automated deduction. And it means if I go to a space, like, I don't know, a Cantor set, scanner space, if I go through the properties, most of these have not been entered in by hand. We did tell it that it's compact, all right, but we didn't have to tell it was sigma compact because, well, all compact spaces are sigma compact, and that's a theorem that the pi base has. So you scroll down here, you can see a few more of the check mark here, and I'm going to show you, we have a better version coming out that'll be a lot more clear to read. But we just have 5 or 6 usually properties per space, and then the automated deduction spits out the rest of it. And if you want to know why the Cantor set is hereditarily Lindelof, well, it's a bit of a journey, but let's see if we can get there. Oh, sorry, that's not it. I clicked on here's the deduction. Maybe it's not too bad. It's compact and completely metrizable. So if we can follow this, compact means sigma compact, as we said, therefore Lindelof. And Lindelof metrizable second countable. So there's of course, completely metrizable has to be metrizable. Now that we're second countable got us hereditarily Lindelof. So there you go. So you can track that down and see what's going on there. That's really it. I think this is a good point, 15 minutes into, and I should clarify my game plan for today. We asked for about an hour, and of course folks needed to drop out if they thought this was only 30 minutes or 20 minutes, and feel free to do so. I am recording this and I'll post this on my personal YouTube and share that. If anyone wants to see that, I'll be available sooner than later. The other thing I'm going to pitch while I'm thinking about it is that we have a slowly growing community of folks. We're trying to get more active research mathematicians involved, especially we talked earlier about how we think there's a lot of potential for students to get involved. This is a way you can contribute to scholarship that is not necessarily the scope of a full original paper, but you're still doing some stuff with peer review. You're still learning some topology. So I think there's a lot of potential there. I love to have students involved in this project. Anyway, the community's growing, and we have unofficially there's a Carolina's topology seminar that meets about every other week. And so on weeks they don't meet, we kind of schedule at the same time a Zoom drop-in to discuss things. And so if anyone's interested in getting those announcements, we don't have those at a regular time because we just let the Carolina seminar, because we all want to go to that, right? So we just kind of see when there's a gap and then we try to meet at that time. So speaking of which, while I'm pitching stuff, Alan, is that open to anybody, or am I just cool?
No, sure. Anybody wants to join our seminar is cool. Yeah.
So I knew it wasn't special. So absolutely, if you're interested in that, reach out to Alan Dow, of course.
Well, actually,
and,
Hector.
Is Hector here? I think I saw Hector.
Yeah, I'm here. Yeah, I can grab my email on the chat.
Yeah, perfect. So he'll drop that in chat. And this is something so I was fortunate enough to spend a year at UNC Charlotte. Thank you again, Alan. My career is drastically different because you said something nice enough about me that let me just teach there for a year. And now I'm, of course, tenured at another institution. So I'll thank you every time I think about it. But yeah, so I got to participate in that seminar when I was in person, and it was a really great seminar. And now that I'm here too far to make the drive every week, it's really nice that I get to hang out with the crowd every other week through Zoom. It'd be good to keep this link. Can it be updated to the Rhodes website? Are you talking about the link to the Zoom, Hector?
Yeah. But question for you: do you think this link can be reused, recycled for tomorrow and probably next sessions?
Yes. So I'm going to, after we're done here, check my calendar. I know I was going to participate for most of the workshop, the conference through Friday. I need to take a second look. Well, Saturday we don't have any special sessions, so I forgot. That's why I wasn't planning on Saturday. So yeah, Thursday and Friday, I just have to make sure that with my teaching, someone can come in and make somebody else host if I can't be host. But we'll get that figured out. I can take responsibility for that.
All right, thank you. Otherwise, I think I have a license too from UNCC. I can arrange also.
Yeah,
meetings.
You probably could as well. I think for simplicity, not having a third link floating around might be better. So, but I'll make sure that you are. We'll get it figured. I'll talk to you afterwards.
Sure.
Cool. Ready. Any other questions about?
Stephen, I have a question.
Sure.
To offer you your chance to tell us your favorite theorem that the pi base has proven.
Favorite theorem that the pi base has proven. Yeah. The pi base hasn't proved. So that's actually interesting. Like I've always had this
string of deductions. I mean, you were showing us deductions.
Oh, sure. And I don't have one offhand. I'm afraid that's something that'd be really good for elevator talk. I've always wondered if there's an open question somewhere in the literature that somebody's asked that's involved in an esoteric enough property, or just hasn't been put enough eyeballs on it. If we could prove something that was an open question, that would be really cool. And I'm sure it's going to happen someday, because as soon as the pi base grows big enough and has more of the literature in it, it's going to be better at making the trivial deductions that if you just don't have the working knowledge of the whole literature, but if we're modeling it or enough of it, that but this is okay. So the point, this is not ChatGPT for topology. This is not going to replace us ever. It's a tool for us. It's augmented research. It's to augment our work as researchers and augment our students as they learn the material as well, because it's a lot more accessible than getting into the literature in certain senses. And we do connect things. We do connect things to the literature. Everything has to come with a reference. And so often, because we started with counterexamples and topology, that's one of our favorite DOIs that we throw in. I'll show how we do that in the back end here in a little bit. But yeah, I will say that it's more so than coming up with proving things. I'm really excited for its ability to give us questions to work on, give us questions to give to our students. I mentioned this a little bit earlier. So yeah, exhaustible by compacts, aka sigma locally compact, is equivalent to, I think it's often defined as sigma compact and weakly locally compact, but it's equivalent to Lindelof and weakly locally compact, also sigma compact as well, right? Because you can see the chain of implications. What it revealed to me is something that I dealt a lot with. So under the assumption of compactly generated, just called K spaces, K omega and hemicompact are equivalent under that assumption. Hemicompact doesn't imply K, but if you have K in hemicompact, that does imply K omega and vice versa. So I only ever worked with it in terms of K spaces. So I always had them conflated in my head. And then I was like, oh, when we sat down to do the work to put this stuff in the pi base, we're like, well, there are hemicompact spaces that are not K omega. They just, they can't be K even in that situation, of course, obviously. And we don't know about the other direction. I have not been able to find, and then we posted to Stack Exchange. I'll pull up that theorem. Well, it's not a theorem. So how do I even, there's some, oh yeah, this S23, space 23. We go to space 23. Oh, I don't have a good way to look up a space by number. I just got to edit the URL. Something else I want to, that's property 23. S23 would be space 23. Well, it has to be a space, not a property. And oh goodness, it wasn't there. Chris, were you in that thread? Do you remember offhand? I'm trying to remember now.
You have 25 instead of 23.
Oh.
That might.
Oh yeah, the Aaron's Ford space. Okay, that's where it came up as the counterexample. And then oh man. Yeah, so it's 23. That was the counterexample, but there's some Stack Exchange post that's cited somewhere in the pi base. I'm trying to think where, probably exhaustible by compacts. All right, I would try that, and then it's not gonna be worth it if I can't find it quickly. So just showing off, can't type. A lot of things have mentioned the word compact. Exhaustible. Why can't I find that? I'm on properties, right? Okay, K-space. Okay, maybe that's a bug. Because it's definitely showing up here. I'll figure that out later. All right. Definitely not worth the time, so apologies for that. But there's a Stack Exchange post somewhere where Math.Stack Exchange where no one was able to answer the question. Oh, I'm being silly. I'm just going to go to my own profile on Math.Stack Exchange. If you're not familiar with this is part of our ecosystem. We have no affiliation with Stack Exchange. We just use them for our own nefarious purposes. I am not that popular in the scheme of mathematicians on Stack Exchange, but here's the discussion that's relevant. Without Hausdorff, what implications can we prove about K omega compared to other covering properties? And so, yeah, here I asked, and no one was able to answer. Maybe I should post it to Math Overflow unless there's someone clever who could answer it right now. And if so, post it over there. Don't tell me now. Post it on Stack Exchange. Get your karma. But yeah, K omega implies sigma compact, but doesn't imply hemicompact. And the answer to that was, well, we don't know. It could imply hemicompact as far as we know. So we only have the direct proof. The pi base only knows about the direct, the direct proof, the trivial proof. So some question to think about. And there's some discussion here that if you're interested, I'll put this link in chat just in case anyone wants to look up on that later. That would just be interesting for my own purposes. All right. So yeah, open questions. What I want to have is, keep talking about things that don't exist yet, but I know vaguely how to do it, and I just haven't had a chance to spit it out, is a button that says open questions. And literally it could just be like a slot machine that gives you something that the Pybase doesn't know about. It would not be terribly difficult to do that. I just have to sit down and try it. Someone asked me, why not? Hereditarily separable. Well, first of all, we don't know what that is. So we need to add the hereditarily separable to the Pybase. And that would be a lovely contribution. Let's talk about, well, let me do this before we talk about what kinds of things are great contributions. And I think from this crowd, almost anything would be. But what I want to talk about first is logistics. How does one contribute? What does that look like? There is this button that says contribute. There is a very sparse, I need to update it, how to contribute explanation here. What I'm going to do is I'm going to take this recording, I'm going to post it to that page right there. And it's going to be the better how to contribute is rewatch this video later, because I'm going to show you what to do. And I should add documentation printed out. But you do need to be on GitHub. GitHub is, very popular in terms of, not just software development, but many areas of STEM scholarship are starting to embrace GitHub and similar Git repositories, which do things. And for us, it's just a place to stick a bunch of text files. That's really what it is. And it allows us to all edit them without affecting each other's work and have a formal process for contributing back our edited text files. And I'm going to show you what that looks like. So before I do that, I'm going to show you how to do it directly. But if you just want to say, hey, you really need to have hereditarily separable, because that theorem would obviously give us this other result. And I don't want to learn how to do the Pybase. It's great what you're doing there, Stephen, but it's just not worth my time. But you're probably better with this contribution that you haven't thought of. Open an issue with your free GitHub account. You can go open an issue and just make a new issue. Your screen, by the way, I like dark mode, #millennial, sorry. It might be white, but it's the same interface, whether if you're logged in. It just might be darker or lighter, depending on your personal preference. But you just go, the button's green regardless. Open an issue and say, hey, doofus, here's a property. Be a little politer than that. You're missing. Hereditary, just post it there. I can't believe I actually posted that. I'm going to close this as rude and inappropriate. So you're going to be nicer than that.
And do you suggest including a reference or anything like that, or just a one sentence thing?
I will take as little as you want to post there, but don't be surprised if you wrote something that concise as I just did. If I say, hey, in order to contribute, I could use a little bit more information. At this point, I'm not going to give you any requirements on what makes a good issue, because if I really cared that much, there is a way in GitHub to actually pre-populate that. And that's probably something that would be a good project for one of us in our infinite time to think about is, what should a person put in default into an issue? And if we do that, then it would have a checklist of things that would you could fill it out like a forum post. That's a good thought, Lynn. Let's put a pin in that for down the road. For now, just literally anything. We are not that busy yet to be refusing even small contributions, small suggestions. But please, if you do this, you'll get email updates probably, as long as your notifications support it whenever you set up your GitHub account, or just keep an eye on the page. And what's nice is we can have a chat about it. What's going to happen, I'm going to go ahead and close this issue because I don't want that to be in my face all day. What's going to happen is possibly, I was mentioning this earlier, but here's where I say it officially. The Pybase is not a tool for peer review. Our goal is to reflect peer-reviewed mathematics, though. And so originally, once upon a time, I had this vision that we were going to reflect the peer-reviewed literature, as in it needed to be in a textbook or a, journal publication of sufficient, whatever that means, reputability. And then we realized really quickly that, no, there's a lot of questions that are like undergraduate topology questions that, if I wake up on the wrong side of the bed that morning, it may not be obvious to me. Or if it's just a little bit outside of my wheelhouse. I do a lot of stuff with selection games and covering properties and a little bit of CP theory. But if you're doing some more heavy continuum theory or something that I just haven't worked with, it may not be, I might not be a great peer review person. Maybe nobody else is actively volunteering for this, because this is all just voluntary at the moment. Long story short, there's better places for airing that out and getting a lot more input from a broader community of mathematicians. And that's where we go back to Math.Stack Exchange and Math Overflow. Is it .net? Is it .com? .org? It's .net. Okay. So if you're not familiar with those, these are also places you can make a free account on. You can post questions. It is hey, I know that guy. What the hell, Will? You're supposed to be here hanging out with us. You're posting to Math Overflow. I'm not. All right. I'm gonna call him out on that later. Anyway, so one of our esteemed colleagues is okay. We're gonna creep on him. All right. He's answering. Okay, so there's lots of we know these names. We know a lot of these people, right? Where is Will? I don't see him. He must have known that we were watching, and he stopped. He deleted his post to hide his tracks. That must be it. Anyway, it's a place to ask questions among professionals. There is a bit of a culture to it. KP, actually, do you mind? Because I know you're pretty active on it and you're here. Why don't you tell us a bit about the culture of Math.Stack Exchange and Math Overflow? What do you think about it?
I don't know really. I just answer a few questions every now and then. That's about it. There are a few people who get really on some high horses every now and then when you pose a question, when you answer a question, because they like to keep the level of Math Overflow high in their eyes anyway. And they sometimes refer you back to Stack Exchange. But most of the time, people are quite helpful.
Yeah, I think it's kind of a meme that these Stack Exchange forums, there's a whole, this is used for software development, like there's other versions that are used for software.
Yeah, there Stack Exchange has, I think Math Overflow is sort of it's embedded in Stack Exchange. But yeah, there is a huge Stack Exchange for tech questions, for example.
Yeah, I think it's
tech or LaTeX or whatever.
Yeah, Math Overflow comes from Stack Overflow, which is the original website. So that's about, if you want to learn how to write HTML or something, you can go there. The point being that I want to make there is that if you go, feel free to be anonymous on there or talk with us and we'll help you make your post there, or we'll make the post for you. Just because there is a bit of a culture to it if you're not used to it. It's a good thing to lurk on, just like a lot of online spaces. As for the Pi base, we're all friends. Please, anyone who's hanging out with us here at STDC for our workshop, we're going to be happy for anybody who wants to get involved in the community. So no problem. Do not worry. There are no dumb questions on our GitHub. So
they're all dumb questions. No.
They are all equally dumb questions. Especially my own. Mine are extra dumb equally. All right. Okay, so where are we at here? So I've said the best way to start contributing is just open an issue. Say we should have this property, or why can't the Pi base prove this, or how do I ask the Pi base to do that? There's a separate discussion board that maybe we should be using, but we're not. Just go to issues, it's fine. Do not worry about posting at the wrong place, as long as you can get into, or email me directly and I'll tell you how to I'll loop you in the right place. Absolutely fine. But let's say, you're here to learn a bit.
Stephen, there's a joke Jan van Mel and I always make at conferences. What about groups? Do you incorporate topological algebra in your
you know what Eric used to say? Yes, and the answer is no.
So you mentioned groups. There is a database of ring theory. It is a very similar concept, convergent evolution. We envisioned the pi base as a more general tool for a more general, categories of mathematics. But just this guy, Ryan is his name, and he's kind and links to us, and we should probably link back to him. Yeah, he has rings and modules and the theorems that connect them for ring theory. So this is not an isolated thing. This is part of why I have, and I'll pitch this while I'm thinking about it. I was fortunate enough to be accepted when I submitted an AIM workshop proposal on cyber infrastructure of mathematics. That's officially upcoming here. Put that link in chat. Please, if you have any interest in mathematical documents, databases, communications, it is open for our applications, and we purposely did not invite as many people as they told us that we might consider inviting, because they said, well, if you want to have a broader, diverse community of folks that you're not already talking to, you can have some more seats available for application. And so we left that open. And so please consider applying to join us, and something for you to consider
But you
as well.
you misunderstood my question.
Oh,
So when you have all these topological spaces with this and this and this property, what about groups?
so maybe I don't know if I misunderstood your question. So you're asking, like, do we track like topological groups, like a space, and what group induces the topological structure? Or
If you add the hypothesis that you are a topological group.
Oh no, we don't have that yet, but that's trivial.
Okay.
Yeah. The fact that something's a topological, I mean, I don't think so. We could check. Oh yeah, we do. Groupable topology.
Oh, okay.
Yeah, because it's a topology. I know we have a lot of funny things, and if you think we should definitely have an alias. We do support aliases. A topology is called groupable if it's homeomorphic to a topological group. We should add topological group as a alias here. But this is another good thing. Look at this. We have no theorems about topological groups. We only have one example of a space that is a topological group, which of course we'd have a lot more automatically deduced if we had any theorems about it. So what about groups? The answer is not a whole lot, but apparently more than I thought, because I forgot we had it. Yeah, please, if you like that stuff, go ahead.
Maybe one relevant comment is that, like, the only structures that exist are spaces. Of course, you have, like, theorems are also objects there, but, like, as far as mathematical structures, space is the only thing. Probably if you wanted to have topological groups like really filled out properly, I think we should consider adding other types of structures rather than just translating everything back over to a property of a space, if that makes sense. So like that, I mean, that,
yeah, like there's a lot of stuff that's really sticky about the way we're modeling things right now. Like, it's talking about wish lists for someday in the future, like not just axioms, but also cardinal valued properties. Like the cardinality of a space is a topological property, and of course that cardinality could be any cardinality, but there's stuff like, what's the density of a space, what's the weight of the space, so on and so forth. Right now we just have to do it by hand. So we have, if you have a size of the reals, and of course that implies that it's not smaller than that, or it's smaller than the same as it, and then somewhere we can get down to countable, smaller than the continuum, and then we get down to somewhere there has to be something about count. Oh yeah, countable implies smaller. Yeah, anyway, you get the idea. Yeah, and because of the fact that we're ZFC, we do not have a property that says size omega 1, because that would be ambiguous. Well, hold on, do we? I know we have the let's see here. First uncountable ordinal. What do we give for that for its size? It's all right, because we don't know how big the continuum is. We say that the first uncountable ordinal is of size the same or smaller or the same as the continuum. That's the best we can do, because we're being insistent on not using cardinals that aren't, beta or not beta, you know what I'm saying, powers of the countable ordinals. Okay, good stuff, good stuff. All right, let me definitely go into, okay, how do we actually make a change? And the way I'm going to do this is I'm actually going to do some homework. So this is just y'all hanging out while I do my homework right now, because I have I'm not going to review this yet. I might do that if we have time, but we do have a request. It's closed. That means that we closed it without actually doing it. There's my buddy Patrick, who's been contributing a lot to the database, and he made a good suggestion that we should add a theorem that says that locally metrizable spaces are first countable. Let me show you what that looks like just from this end. He made a whole new theorem. It did not exist before, and now it does. I'll show you how he did that in a moment. And there's a bunch of boilerplate. It says that if you have property 82, what's property 82? Well, someday, speaking of things I want to happen in the future, someday you should be able to click on it and it just tells you or hover over it. For now, I just got to go to properties and then change the property to 82. Locally metrizable. Okay, he did the right thing. Locally metrizable implies, if I can find the right tab, 28. I'm going to hope that's first countable. Sure is. And that's true. You know, the first countable is a local property. So given a point in an open neighborhood, we get a countable local base because, you know, the metric that induces the local base of that space, right? We did not reject it. We agreed among the two of us that this is correct, but we thought, oh, actually, maybe it'd be nicer if we added locally pseudometrizable as a property, because locally metrizable is making an assumption about, you know, T0, you know, separation. And we thought, well, actually, you know, maybe we're cool with pseudometrizable instead. Even though I don't know, has anyone ever published a result on locally pseudometrizable? That would be oddly specific. You could always quotient it down to get locally metrizable, right? Probably just do all your work there in T0 land. But just for the sake of you know, organizing our ducks a little bit, we thought, hey, let's add that as a property, because that would allow us to get pseudometrizable implies locally pseudometrizable, and locally metrizable implies locally pseudometrizable. So we're never ever going to actually mark a space as locally pseudometrizable unless we really, you know, have a locally pseudometrizable space that's not locally metrizable. I guess that we might do one just to have it in there. But the point is that now we have we can update this theorem that we do have, which is too strong. Pseudometrizable implies first countable. I want that to be locally pseudometrizable implies first countable. And then I'll just say elsewhere that pseudometrizable implies locally pseudometrizable. All right, how the heck do I do that? Let's show you. So this is the discussion that we had. And then I told him, actually, we're going to do this right now. And he said, that's a good idea. So I have permission to just do this right now for y'all live. What's really cool about Git and GitHub and all this fancy software developer-y things, and I'm doing this for lots of different projects in math and math education these days, and I'm working with lots of folks that don't want to learn Git and don't want to learn GitHub, and you shouldn't have to do your job as a mathematician. I completely agree. What you can do is either take .com and write it as .dev, or just press the period key. You can't see it. There's my keyboard. I'm going to press the period key. And magic happens. Okay, if you're logged into GitHub, this is a cool trick. I said this and I'm realizing this works for me because I have access to the okay, there's one extra little step. If you want to do this, talk to me and we'll go through it directly together. But this is more or less what you do. Is you go into this .dev editing environment. You don't have to install anything. It's just on your web browser, and it has all these text files. MD files are just text files called Markdown. There's some special formatting rules. You don't have to know all the ins and outs. You just have to know, if you just don't want to make an issue, which go ahead and do that if you like. How do I make the contribution? So what do we say we're going to do? First things first. If I can go back to .com. I'm going to pull up my notes so I remember what it was we said we were going to do. I said we were going to first update. No, okay. We want to update theorem 57 to say locally pseudometrizable implies first countable. Can't do that until we have a property called locally pseudometrizable. Let's create that first. So I'm going to go to properties. I'm going to scroll all the way down. Again, things that should be nice is there's ways to hack this, to put little buttons to do things that are kind of tedious like this, where you copy paste a file and rename it. I do have some of that in mind on making this easier to do, but I'm going to call this is now a new property that we're going to contribute called locally pseudo-metrizable. And we're probably going to get rid of this soon. I think we're not really using this, but we have like this little
You may want to spell it correctly.
I knew I was going to spell it wrong. Pseudo. If that's wrong, don't tell me. I don't want to know. I don't think we have any aliases for this, so I'll just get rid of that. If you think of a good alias for it, post it in chat. I'll add it in a second. And probably we need to add some references to this. I think, it's really good if you could post something like related to an article or a textbook. I really don't know if locally pseudometrizable. I could probably cite, my favorite textbook and just point to pseudometrizable, right, and locally metrizable in it. I'm going to leave this as a to-do, so this is going to not be accepted as is. I'll just say to-do. I'll figure that out later, what a good reference is for it, so people know I'm going to stop making up nonsense for no good reason. And of course, I should give a short little description. And so usually I like to write it as a predicate these days. So a locally pseudometrizable space is a space such that every point has a pseudometric. And if I'm doing this live, I'm probably going to say something stupid. So if I'm saying something technically wrong here, suggest a better notation. Has a pseudometric inducing a local basis. Or is it, does that work?
Wait, why not just say it has a neighborhood that's pseudometrizable?
Oh, yeah, has a neighborhood.
Maybe, I don't know.
It has a basis because we're calling it locally. So it has a basis of neighborhoods that are pseudo-metrizable. Much better. Okay. Like I said, I'm doing this live. I do bad math. First, the closer you get to a chalkboard, the worse your math you do. At least that's me when I'm teaching. It's the same concept here.
I don't think that works, actually. I don't think it works.
It doesn't work. See, I should have thought of this like 2 seconds ahead. So
because you could, the point itself, you want the pseudometric one pseudometric to give you a basis at that point, right? Where you could keep,
yeah.
because you could
Okay.
have your pseudo. Yeah. Anyway. Yeah.
well, what we should do for consistency is how do we define locally metrizable? Well, this is how if each point has a neighborhood which is metrizable.
Yeah, that's what
so
you need.
That's
Yeah.
what I need. Okay, so we'll do.
Look,
But that's different than having a basis of pseudometry. Okay, so
yeah, because the topology at your interesting point could be always a stupid, like you got a neighborhood and then a stupid. The pseudometric has a stupid property at your favorite point.
well, they all would have to induce the same topology, right?
We didn't say that.
Okay. Maybe that. Right. Okay. Right. Okay. For now, I'm going to word it like this, but this is, of course, why we have discussions in the pull request, and we will actually review this before it gets merged to the live website. I will show you how we can see what it
You
would
did
look
repeat
like.
your favorite spelling mistake.
Dang it.
Just add another definition.
I did this. Oh, actually, there's a way to get around this. Pseudometrizable is in the pi base. Of course, I can't find it unless I can spell it correctly, so wish me luck. Okay, property 121, P121. Okay, Perfect. That's going to hyperlink it. And so it'll help people get to the definition of what pseudometrizable means, and it'll prevent my spelling error. So we're good to go. All right. One of the conventions we have is basis versus one open set, though. And so I am interested in whether we should call this weakly pseudometrizable. I don't know, but versus
Well,
regular.
locally connected is like that, isn't it? And locally compact.
We might call, well, that's why we have weak local compactness, which is different from local compactness. And that's, yeah, we need to think more when I'm not trying to explain how to do the thing, what makes the best fit for consistency.
The others
of the
are
database.
covering properties, and this is different. Yeah.
Yeah. So we'll think about it. But in any case, we're going to roll with this for our
You're
property.
working with terminology that's been thought up by very many different people. So good luck putting that all straight.
Well, right. And this is part of why, we like to have these little IDs. There's no ambiguity. We could all call it something different. And of course, maybe I'll have someday an alias, which is weakly, locally pseudometrizable. And that's going to, be showing up in searches and such, right? But in any case, yeah, that's a huge pain in the butt. And so that's why we do things like, for example, separation axioms. Tn implies Tm whenever n is greater than or equal to m. Okay, that's how God intended it. I don't think that's how Stein and Seebach did it, but hey, that's one of the conventions that we went with. But really it's just P7 for Hausdorff or whatever. We have this kind of, hopefully maybe someday if this gets popular enough, we'll have a canonical, what is it? Oh, there's one that always comes to mind, like monotonically paracompact. It's different whether you consider star refinements versus locally finite refinements, even though paracompact, they're the same. I think that's right. Something like that. Anyway, I'm gonna actually finish the thing. So I've got the new property. Now I need to fix, what did I say? It was smart at the time. I'm gonna update theorem 57. And we try to keep our theorems, we don't edit them to something completely irrelevant, but if we can generalize the theorem, we will update it. And so I just call that new property 144. So I'm just going to put that in place. Is locally pseudometrizable. Actually, I could just do the shortcut thing so I don't misspell pseudometrizable. If the space is P144, for any x and x, the ball of radius x is a countable local base at x. Let's see. Yeah, where you assume that that's the metric relevant to the, using the local pseudometric. Oh God, I'm stuck. For the point for a neighborhood. All right. And again, I'm going to have to edit this later, but for the purposes, let's keep moving. I've got a theorem, I've got a property. What else do I need? I said that we were going to have pseudometrizable implies locally pseudometrizable. That's got to be a new thing. All right. So I'm going to go down and make a new theorem. I always get shocked that we have way more theorems than spaces and properties, but then I remember it's like, in choose two sort of situation. So I guess it makes perfect sense to have more, but anyway, theorem 326. So annoying, obnoxious repetition, fix that. And we're going to do pseudometrizable. Is that 57? No, what was pseudometrizable? P121 implies P141. And again, I'm going to edit all of the references and the descriptions later before this is actually merged. But I think that might have been everything I wanted to throw in. So the goal was just to add locally metrizable implies first countable. And now instead, I've got pseudometrizable implies locally pseudometrizable. Locally metrizable implies locally pseudometrizable. Oh, I don't have that yet. I need to add one more. Locally metrizable implies locally pseudometrizable. That's one more copy paste. One more rename.
Do you really need that?
Well, how else are we going to know that all of our locally metrizable spaces are locally pseudometrizable?
Metrizable implies pseudo, or metrizable implies pseudo-metrizable, so you can't
But-
figure out local versions. I guess not, because local isn't well defined, hey?
Yeah, the pi base knows nothing about the semantics of the words that we're putting into it. We have to hold its hand and literally tell it that, yeah, so exactly right. Now that's okay, add that to the wish list. You know, it would be really nice if a lot of these patterns that show up in topology, you know, the notion of what local or weak local means, right? If we could just have this schema that says for every property, here's what the weak local version of it means, or the local version of it means, that would be great. Also cool stuff like you know, CP theory, right? If X is omega Menger, then CPX is kindly tight or something like. I'm saying stupid things because I'm being recorded right now, but you get the idea, right? The pi base doesn't know that space that 1, 2, 3 and space 1, 2, 3, 4, that they have that CP connection. There's no way for us to model that currently. There's no way for us to model theorems of that form. And so all stuff that would be really interesting to explore down the road. And this is part of why I want to do this workshop. And I got a bunch of people doing databases in other categories of mathematics, so they can tell me, duh, Stephen, this is how we did it for our stuff. And I'm like, oh, that's perfect. I can just do what you did. Or use your software if you wrote it abstractly enough. We're going to find out.
I interrupted you.
Yeah, that's okay. I'm very easily interrupted, so no sweat. I should go ahead and try and wrap up a little bit by 5 after, but I'm not running off. If people have more questions.
I meant you were going to introduce that new theorem, and I interrupted you.
I should also do that. Yeah, because that's identical to the last theorem. I now need to have what was the new theorem? Locally metrizable, which is oh, there it is, 82. Locally metrizable implies locally, and I'm going to edit all the references and language around it. I think that's it. Check my work. Lynn, Chris, does that sound right? Okay. How can I review everything I've done? I'm going to close all these windows, first of all. Try to close all these windows. Okay. And I'm going to go here to source control. As I edited stuff, you probably saw this little nagging little number 4. That told me that I screwed with 4 files. I added 3 files and I modified a file. So all the new files I have is adding that new property, adding the theorem that if I got my IDs correct, that you know, locally pseudometrizable implies pseudometrizable. I think that's this one actually. And then pseudometrizable implies locally pseudometrizable. And then I edited the thing that used to say that pseudometrizable implies first countable. Now it says locally pseudometrizable implies first countable. And I'm ready to contribute that. And so to do this, first of all, I could, because I'm special, I could just push it and make it part of the pi base, but I'm going to be good and do what y'all would do. And I don't do this myself either. I make sure people review my own contributions because I screw up all the time. I'm going to open a new branch. I'm going to call it STDC demo, because it can be called whatever you want. Usually you pick something more semantic, but I'm going to switch to that branch. Okay, so now it should take all those tweaks that I made, and it'll give it a moment to reload. And God willing, it didn't screw up. Yep, it's all here. And now now that I'm on this new feature branch, is the fancy software engineering term for it, I'm going to say add results to show that pseudo metrizable implies first countable. I don't need to show that again. I'm going to commit and push. And what's going to happen is I'm going to go back to the pi base. And again, this is a little bit different if you don't have access to the pi base itself, if you're doing what's called a fork of the pi base, and I'll just personally walk through anybody who wants to go through that process and start contributing. Or honestly, I may just give you direct access to the pi base because there's not that big of a project and I trust all of you. And I can revert things if things get screwed up. Git is amazing. It keeps track of every single thing you do along the way. So if you screw something up to a certain extent, you can always undo it. But here, my STDC demo, thanks Lynn, had recent pushes. I'm going to compare and pull request. And so I would normally say some more things about explaining what the heck I did here, but I'm just going to create the pull request. And so a couple things happen here. First of all, we found out that I screwed up because before it could be merged into the Pybase, I didn't do this on purpose. This is just me actually failing. Is that apparently something I did is impossible. Path is not, okay, that's not it. It's just something stupid. What I forgot to do was update theorem 327 should have ID 327. I don't like that I have to do that. I'm going to fix that, add that to the list. Fix T327 ID. All right, so I commit and push. Now I'll just go back over here to the pull request that I made. That yellow thing means it's thinking. And so magic is happening that you don't have to worry about, that's going through and crunching through all the logic and trying to figure out, hey, does this thing actually make sense? And I'll just refresh here, and hopefully that's a green check mark now. Beautiful, verified, valid. And so I made this pull request. I should have made it a draft. Chris, I'm going to put this on you so that Patrick doesn't make fun of me for making such a bad pull request. In any case, you can see the files that I changed here. It's exactly, we can make comments on the line, like, for example, hey, this reference needs to be updated, right? Stuff like that. You can start what's called a review or just add a comment. And then it's all there in the context of the contribution, the conversation. It's all got this flow of conversation. This is all just GitHub magic wonderfulness features that help you collaborate on multi-user software, essentially was what we're doing here. What's also really cool, again, this is something that's special to me currently, and I think the best solution is if you want to get involved, I'll just let you access the actual database yourself, and you can do what I just did. But in the long term, I want other people to be able to do this, even if they don't ask permission first, is that you can take that branch, STDC demo, you can go back to topology.pybase.org. There's a special secret URL called /dev, and you can change the branch to stdc.demo/demo. And it's going to go through and it's going to take those contributions that I made. It's going to check all of them. This is how we can do our homework. And when we get a review, see, oh, does what you wrote actually make sense? Because I don't have what P14441 is memorized. And I would really like to just see it all in context. So if we go back to properties, if I can spell pseudometrizable, here's my new property. This is not in the public Pybase. Incognito mode, public Pybase doesn't know what the heck that is. That's not part of it. It's only on this, little branch I made. And all I know about pseudometrizable is that it implies first countable. Although I do also know there's a lot of spaces that are not locally pseudometrizable. There's also a lot of spaces. Oh, I expected more spaces that are. Because I thought all pseudometrizable spaces would be. So maybe I have something to fix. But in any case, it did do a lot of the deduction for me.
Really quickly, I think you might want to check the theorems because I think you put 141 and I think the ID was 144, I think. Yeah, so 144, and I think the theorems, yeah, so that theorem said 141 was the concept.
That's why I messed it up. So locally pseudometrizable is 144. And so apparently I put something in that was plausible based on what the Pybase knew, but not correct. So I'm trying to prove, okay, what's this theorem supposed to prove? 327, just go to the bottom. Locally metrizable implies generated by maps from compact Hausdorff spaces. Okay, I got to fix both of those theorems. Both of those theorems are supposed to be 144, not 141. All right. Fix typos and P144, commit and push. And what's that going to do? You can see it. It showed up right here automatically. It's thinking about it. It's working. God bless it. It's a little brain, a little computer brain. Still thinking about it. You can see it. Yeah, maybe it'll update automatically. I get impatient. Just hit refresh. Oh, it's showing up down here too. Some checks have not completed yet. I'm gonna try to get to a good stopping point in just a second. Thank you all for hanging out with me this afternoon, and if you have more questions, oh, it passed. Now, if I go back over here to the pi base, I go back to my, I'm going to refresh it. All right. I never would have figured that out, Chris, without your help. Thank you. So locally sudo PS, I could do PS. Now I have all the theorems I need. Pseudometrizable, locally metrizable imply locally pseudometrizable. That implies first countable. And I've got a bunch of spaces. The pi base, no one's ever told the pi base any of these spaces are or aren't pseudometrizable. Every one of these things is automated deduction. And so I have a little bit of like, quality review to be done, but I think mathematically the content is correct in this pull request. So I will work on that asynchronously from this chat. What I think I just want to do right now is just formally thank everybody for hanging out with me for an hour to learn more about this. I'm going to hang out for questions. I'm going to keep recording too, but I did want to give folks an out if you were ready to head on out. But if not, I think at this point, I'm going to just go into question mode and we'll let things wind down in the next few minutes. But thank you all again.
Thank you.
Any questions?
I have one remark, and Alan, maybe you know this too. Didn't Murray Bell have a database of compact spaces?
I don't know if they were just compact spaces, but yeah, he had a database, but it died. I don't mean to make this a joke, but it died when he died. I mean, his wife inherited it, but she didn't make it public, and it was in a.
Didn't Topology Atlas inherit it eventually or not?
I don't think so. It was on an Atari or something like that. It wasn't portable. But he, like Steve was saying, I mean, Murray, he generated some of his own questions by the completeness of his database, and he published, I don't know, probably 2 or 3 papers. When he identified a hole in the knowledge base, and he said, "Oh, what about this?"
I have not heard of this project before. What was the name of the person?
Murray Bell.
Murray Bell.
Bell's
let me stop
Yeah.
sharing for a bit, and I'm gonna Google that so I have that in my Murray Bell math. Okay, I've got a page on him from the Defunct Topology Atlas. I will dig into what I can find out about this on my own. I may bug you for more information later.
I doubt you'll find out very much. I mean, because it was not too many people knew about it.
But even if I just find his old papers, maybe I could find, or do you think, I mean, I guess, right, probably didn't mention it in his papers. It's probably just something offhand that he told folks, like at
right.
conferences. Yeah.
Exactly.
So it's a shame that is a fact of how mathematics has been done and nothing I can cite when I go to funding
Right.
agencies.
Next time I talk to Jan van Miller, KP will probably see him sooner. We can ask if he remembers very much about it.
Yeah, I would love to hear more about that. Cool. Thank you.
I'll make a note. I'll be talking to Jan tomorrow morning.
Yeah.
Yeah, any prior art, prior work, showing that these kinds of things have value and not just, curiosities or neat little gimmicks, but like actually advancing mathematical research, of course, is very much the kind of thing I want to have in my back pocket as I go seeking support for these sorts of projects. So I really appreciate that. Any other questions or remarks? Critiques of my spelling?
One question that's not directly related to pi base, but it's something that I've mentioned before, and that is we need a replacement for Topology Atlas that will tell us about upcoming topology conferences.
This is in the scope of the workshop I'm running this December. It's probably, we have so much we want to talk about, but I want to make sure we have at least one little bit of discussion of, it's kind of like, it's not really about documents or databases, but it is sort of about communications, right? And I do think, and I was never a heavy user of the Topology Atlas myself, other than when conference proceedings happened through the Atlas. That's how I submitted, like everybody else, from whenever I got active in the early 2010s until it stopped in 2020. it's infrastructure. You know, this is the thing that NSF purports to support, is infrastructure and cyber infrastructure. And I don't know if there's any equivalent notion of the topology atlas that's being used in other fields of mathematics or other fields of science and STEM. That especially anything that's free and open source that people can just use. I do know that the question and answers market's pretty well served in math by Math Overflow and Math Stack Exchange, and they are open enough in their data that I don't feel like there's just, I don't think it's worth our time to replace that aspect. But definitely the logistics of running this event that we're here right now in my own personal Zoom, because everyone has to reinvent the damn wheel every time we want to run a virtual conference or publish proceedings. And Chris, you know, so sweet and letting me have this workshop at all, because it's just extra work for him to do at midnight last night, trying to get all the files put in the right places. And all this is all stuff that could be push button if I had funding for, you know, a couple of undergraduate students. Like I could put something together that's usable for pretty cheap.
Steve, you might want to get into contact with David Chodonsky in Prague.
Okay.
Because the Winter School and Toposim have been running on the same software for, I don't know, 10, 15 years already.
All right.
They have it pretty well automated there. So they might be able to give you some hints.
Yeah.
On how to set stuff up. Yeah.
And so this is the thing that, you know, getting on one of my many soapboxes where we it's great that they've got, I didn't know about this, and I don't purport to know everything about the cyber infrastructure of mathematics. It's really just become my thing in the past couple of years. But not just building these tools, but building them in a way that's replicable, not just if you're in the know, is one of the big capacity building sorts of, you know, jargon.
I think
stuff, you know.
Jonathan Werner was one of the major writers. He left topology, I think.
Who is? Sorry?
Jonathan Werner.
Okay.
Why don't you say it in English, KP?
Jonathan Werner.
I was trying to see if I'm at toposim. Website here, and I'm trying to see if there's a contact. I may just have to bug you and Alan directly about both of these connections afterwards while I'm thinking about it. But yeah, that is a fundable having. What do you have to say? I reviewed for an NSF. I can't tell you what I reviewed for, but I can say that I have a pretty good suspicion that a robust, beyond just general topology, set the right topology, but a tool that would serve mathematicians across the country, it is always a matter of the right scope, right? Because if you go too broad, you're not going to build a tool that's going to serve everybody. But I do think I think you could build a good tool for mathematics in general that would automate a lot of the needs that we have as scholars in terms of making, you know, these sorts of events pretty turnkey. So yeah, taking existing software, if it's free, open source, modifiable, or they're just willing to share it, perfect, great. But there's money to be gotten from funding agencies that are interested in these sorts of things. And it's not money that we usually get. It's not from the same people, from the little buckets of money that we usually get it. I am, you know, epic humble brag. I have too much work to do that's funded that I can't write too many more grants, but I'm very happy to share what I've learned in terms of these more novel, like infrastructure mathematics grants. And if others want to pick up the mantle, I'm literally trying to open an open source program office on my campus where my job would be, instead of teaching, helping people write grants like this that would build up infrastructure around research and education and all that kind of stuff. So I'm very interested in conversations if others want to take the lead.
Well, some of the things in Topology Atlas weren't so labor intensive. I mean, sometimes you just get just a description of the dates of a conference and a link to the web page for the conference, and that's all that's needed.
Yeah. But that wheel probably has to be reinvented because the software that they were using or the underlying programs don't really work anymore.
Yeah, I would definitely, it would be easier to build something from scratch than it would be to maintain a legacy piece of software that started in 1995. Do I remember that right?
Something like that. I seem to remember they built it on Perl.
Oh God. Sorry,
well,
I deal with
Yeah,
web work
yeah,
too
Perl.
much.
Perl was it in the 90s. So
Oh yeah, that's why web work is based on Perl. If you use that for your homework system.
Yeah. You mean Elliott Pearl?
no, without an A in it.
Oh, any other thoughts or questions? Do I need to turn off the microphone or the recording so that you can ask her real questions? What's up?
Well, it's not really a question. It's just like, or let's say I have plenty of questions, plenty of things to say, but not now because I'm in France and I want to sleep soon. But basically, you know, I'm not really a topologist, even if I'm speaking at this special session. I'm more of a Banach space theorist / combinatoricist / everything at the same time. And a few years ago, I was thinking about doing the same for Banach spaces, and I started to talk about it with people. And it appeared that in the meantime, like I think 1 year ago, some other people had the same idea and started to do it in parallel with the PyBase. So I did not join them yet because I don't have time currently, but I intend to join them soon. And I had plenty of ideas of things to implement that I was planning to ask you about. And I realized that all of those have been talked about tonight, like properties depending on parameters, like on cardinals or on real parameters in what concerns Banach space theorists, or like schemes of properties like local something or hereditary something, etc.
Yeah.
So these all are very interesting things. Thanks a lot. I think I will join them at some point and I will tell them about this conference you're organizing in December. I think that personally I won't be able to join, but in case I can, maybe I will.
Yeah.
And last, maybe I have one question, which is, how has it been received in your community? Because I remember when I started to talk about that to colleagues, the first time I really talked about that broadly, about my idea, about my idea of doing this for Banach spaces broadly, it was at a webinar we had during lockdown with Banach space theorists worldwide, and there was a guy, a big guy, in Banach space theory, who is not an old guy. I won't tell you who he is, but he's someone to whom I owe a lot, and that I estimate a lot. And I mean, we already discussed several times about math with each other, and really he's a nice guy, but he told me something that completely discouraged me. He was saying, but that's not how mathematics are done. And I was kind of, wow, but I'm not meaning to do mathematics this way. Just this can be a tool among many others. Did you have any reactions such as this one in your community?
No one has gone that far, to me personally. Maybe behind my back, who knows? But first thing I have to always say to that is that I'm still waiting. I think we're only a year or two from the first artificial intelligence peer-reviewed paper. Like someone's going to get a bot like ChatGPT to write a research paper. I mean, it's probably already happened in some like crap, journal somewhere, but like a plausible and I don't think that they're not going to prove anything novel. I think it's just going to slip through. Okay, there's going to be something at,
yeah, of course.
Yeah, and so some reviewers are going to be lazy and they're going to get really embarrassed afterwards. Probably won't review for that journal again, but it's going to slip through in the next year or two. Those tools are only going to get better, and I'm a big believer in not saying that we shouldn't do things this way, because that's we can't control that. I am a big believer in thinking about how can we take advantage of this stuff to do what we actually want to do better. And you know, the Pi base, like I said, you know, it's not a tool to prove stuff for us. It's a tool to automate the boring stuff, right?
Yeah.
The literature review, you know, or you know, God, like I don't have a full in my head everything that's in the Pi base, and I certainly didn't when I was a PhD student or a master's or an undergraduate student, right? So like this is a great like equity sort of situation, like get the inclusion sort of solution to get more people into the field quicker without some of the barriers that have historically kept, you know, keep folks, like, slowed folks down from participating. In terms of like locally, like I had a talk with my chair. This is being recorded. Okay, I'm gonna turn off the recording. So thank you if you're watching the recording. I'm gonna spill the tea in a second. So you'll have to ask about that later. But y'all thank you so much for watching the recording. I'm gonna have some real talk.